Yeah, we're live. We're live. Oh, there we go. Now we're live. Apparently, we weren't live when I was doing my Yaps live, but now we're live, so it's all good. So tonight we're going to talk about a couple things. First of all, the video that I just posted today was a comparison of the M90 Gen 5 M90 supercharger versus the turbo, and so it's the age-old comparison. Which power adder do you want? Do you want a blower or do you want a turbo? And as we discussed in this, and we've discussed many times on the different LS platforms, and I have videos up on the channel already covering not just the M90 versus the turbo, the ubiquitous GT45 turbo, but also I have the modular Ford test where I ran the Eaton supercharger, the twin turbos, the centrifugal blower, and the twin screw all in the same combination, same air fuel, same timing, same boost, all of that stuff. So you can see what that does. And we did a similar combination, a similar test, testing the different forms of force induction on a Honda B series motor. We ran a Vortec, a Jackson Racing, and then a turbo, again, all the same boost levels, same air fuel, same timing. And I did also a similar thing on a small block Ford where we ran a turbo and a Paxton and a Roots, I think it was a 174, a Y-end Roots blower, again, all in the same combination. So you guys can see how all of those do. But this was an interesting test. Both of these are fairly low dollar options for blowers and for turbos, because you can go to the wrecking yard and get the L67 or L32 blower, in this case on the Gen 5, and you can get those superchargers and they're readily available, and guys adapt them to different kinds of things. You can also, the GT45 turbo is a few $100s or whatever, and they're very inexpensive to get. But there's a lot of things to discuss rather than just the generic, like, which one would I pick? Would I pick a turbo or would I pick a supercharger? Because these two things that we ran, one of them is an 800 horsepower turbo, and the other one is more like a 500 or 600 horsepower supercharger. I know guys are going to tell me, oh, but Joe Schmo in Australia is making 8 million horsepower with an M90. It'd definitely be the exception and not the rule. The M90 is not a powerful supercharger. If you maximize the airflow to it and spin it past its rated RPM and change the bearings in it and change the housing and do all these things, then you can make more power with it, but still never great power. It's not going to do anywhere near what the turbo can do. The one thing it does do, and this is pointed out in all of these other videos where we compare the different forms of force induction, is they do different things. And that's the great thing. That's what a lot of people forget, is that we're not picking one ultimate thing. A guy that picks a turbo is going to badmouth the blower and talk about parasitic losses and charge temperatures and all these things. And because he's a turbo guy, and he's going to say, like everybody does, whatever the thing is that I want is the best thing. And so not only do I have to have that, but I also then have to put other things down that I don't like because they're not my thing. So my thing is the best thing. It doesn't matter what that thing is. And that's just nonsense. The great thing for all of us, is for performance enthusiasts all over the world, is that we get to choose. It's better to have a choice. If there was only one, then we know which one we would pick. We don't pick the only one that's available. But it's kind of cool to have a Roots blower or a twin screw blower or a centrifugal blower or a turbo, an electric supercharger, if you can make that work, maybe at lower boost and flow levels to get the electric motor to generate that, whatever it is. But it's better that we have those choices. It's nice to go to the grocery store or whatever and have choices, or have different headers that you can pick, or different camshafts that you can pick, and all of that. By the way, the sloppy best and the Truck Norris camshaft test is coming up with lots of good data, because there's even more involved there than the test that I just did recently. There's actually a lot more information. So there's good comparisons between, for instance, the Truck Norris cam and the torque cam and a stage 1 cam, and lots of good stuff there. So that's coming, and I know that everybody wants to see that, but that is coming. But on the choices, it's good to have that. So if you want, and I covered this in the video, that if you want like immediate throttle response and boost response, you're going to be hard pressed to make a turbo do what a Roots blower does. When you step on the gas, you get immediate boost response. You don't often get that with a turbo, and you can size turbos so they come on fairly early in the RPM range, but still they have to have exhaust flow and temperature and pressure to make the turbo work. And it will never do exactly what a mechanically coupled supercharger does. And so we showed that even where we were making in the comparison between the blower and the turbo, where we were making essentially the same power at the top, the turbo made a little bit more, about 10 horsepower more. But if you look at the bottom end of the scale, it's way down on low speed torque compared to the roots blower, because the roots blower just has a lot more response down there. Now we could, and we talked about this in the video, we could improve that dramatically. There are other ways that we could, improve that low speed response even at that boost level. Obviously, we would pick a smaller turbo. We wouldn't pick the GT45. I just happened to have that. It was already hooked up. It was convenient, so that's what we ran. And it would take us to where we eventually went to, and even more than that. But we would pick a smaller turbo, certainly would be one thing. We would also pick a different intake manifold. The one of the problems that I think with a roots blower and twin screws and those kinds of positive displacement blowers, one of the things that limits them is that they usually have to combine them with a very short runner manifold. And we saw this in the factory M90 on the L67, but also on other applications too, on an LS application, small block Chevys, big block Chevys. When you put those root style blowers on there, they're almost always combined with very flat short runner manifolds, so that it's primarily for packaging, so that you can fit the things in, in this case on the M90 for the L67, so you can fit it under the hood. And so they package them with small. That's why one of the reasons that it didn't have an intercooler also was because it's very hard to package that. So short runner manifolds work very well for that. And the argument, for that ostensibly is that, well, we have immediate boost response. We don't need runner length. Well, it would be better if you did have runner length and immediate boost response, then it would be the best of both worlds. That's one of the nice things you can have with a turbo. If you're putting a turbo on, you would use and I would have done this for a street application, a smaller turbo, and then the long runner factory aluminum or composite intake manifold would have improved things dramatically down low. And if you want to get an idea, take a look at the intake video that I did where we compared the long runner, short runner, and even this one that we ran with the hogged out M90 supercharger casing on the short runner manifold. You can see exactly what happens. We pick up a ton of low speed power just from having runner length in the manifold, and the blower thing would do that as well, which would be good and it would be beneficial, except in the application what I'm trying to do with it when we're prepping it for the big bang. We don't want big low speed torque numbers. We want this motor to make more horsepower than torque, certainly at the peaks, but also limit low speed power, because the torque really is probably what's going to break a connecting rod and or piston, and we don't want that to happen on the big bang deal. So I'm purposely doing that. But were I doing this for a street application where I wanted better response, smaller turbo, long runner manifold definitely would be the way to go. And we certainly could do that. And we had that option available to us. Again, we just didn't do that. For one, we didn't choose the right turbo. And then obviously I designed it so that we could run higher RPM and make power at the top and not have lots of low speed torque. As it turned out, even when we turned the boost up, we had plenty of torque. I mean, when we were running over 600 horsepower, we had 555 foot-pounds of torque with the turbo. So it's, traction is definitely going to be a concern running that kind of torque output with these turbocharged V6 combinations. It'd be much better to have that package, in my opinion, in a rear-wheel drive chassis, obviously, like in a Camaro or Firebird or in an S10 truck or whatever you're going to put it in. Get the thing so that it would hook up so you could utilize all that power. And I think we're just scratching the surface right now for what this thing is. I think I could have gone up quite a bit more in power, but we want to do it correctly. I want to put ring gap in it. We want to put the right kind of head gasket and head studs and stuff in there. When we do that with the stock bottom end, I think we're going to go fairly far. I'd be surprised that we're not making some fairly big numbers before something happens that's kind of catastrophic with this. But it all worked out well. And the thing that I like the best about this is I demonstrated in the video that I demonstrated a dramatic change in charge temperature. And I want to talk about that a little bit because it's interesting from two perspectives. One, we went from, we saw on the turbo application, even when we were running the boost the highest at 14.5 pounds, we had very low charge temperatures. We had low starting charge temperatures, which is good because we're not constantly circulating the hot air like you are with the supercharger. So you have a lower starting point, which is better because if you have a lower starting point, you'll have a lower ending point. Also, we had less of a rise during the run because the turbo itself puts out less temperature compared to the blower. And our intercooler system was probably better too. The air to water, both of them had air to water intercoolers. Both of them were running E85. So both of them were well within the range of the safety margin. But the air to water intercooler we used on the turbo is definitely has a higher flow capacity and more charge cooling than the system that was run on the blower. And again, a lot of that is just fitment and packaging. You can't fit a big, thick intercooler. If it's a sand rail, then you have all the room in the world. But if you're trying to fit it actually under the hood of something, it's hard to package all of that. And so, you know, the discharge area from the supercharger is small, and subsequently the brick that they use for the intercooler is small. So there's going to be limited charge cooling when we get up to very high flow rates and also very high temperatures, which with the blower, you'll get to very high temperatures. We know we have gone over 220 or 230 degrees of discharge temperature coming out of the blower. And we hadn't even spun it up very fast. Lucky for us, we were not, when we were running this thing, we already had ported heads. We had a good sized cam, and the NIC cam is designed apparently by ZZP to lower the boost pressure, to lose boost, if you want to design a cam for that, so that you could run it in non-intercooled form and bring the boost pressure down to bring the charge temperature down and help you with knock retard and all that. So by making the motor more efficient, we're bringing the boost pressure down, and then it makes life easier on the intercooler that we were using, because we have less boost pressure, you have less temperature. But we saw the difference. Even at the highest boost level with the turbo, we were still under 100 degrees. We were only about 95 degrees, I think, if I remember correctly. And even with an air to water intercooler on the blower with a 2.6 pulley, it was only making a peak of about 12 pounds, 12.1 or 12.2 pounds. We were over 130 degrees of charge temperature after the intercooler on the supercharged combination. And while that might not seem like a lot, Richard, that you only raised it by, 30, it was 133 versus 95, I think. So almost 40 degrees. That's not very much. Well, no, 40-degree change is not a lot. It's easy to live with. You can get that kind of variation in a non-intercooled from run to run. So really, that's not that much. But look at it as a percentage change. If you look at a 40-degree change from a 95-degree starting point, that's a big percentage. It's more than 40%. So that's a big change in charge temperature. And one of the things I talked about in the video is that it goes to show you that not just from a temperature standpoint, like there's a power loss from running the blower, just from the parasitic loss associated with driving the supercharger. You have to spin that. So like an air conditioning or a power steering or a water pump, it takes power to drive that. It takes power for the blower to move that air. And so the faster that you're spinning it, the more air you're moving, and the higher the boost is, the harder it is for things to work. And so it's costing you more and more power. But that's not the whole thing. It's just not a very good air mover. It's not very efficient at what you're asking it to do. And especially as we go up in blower speed and go up in boost, it gets worse and worse. Whereas the turbo doesn't suffer from that. We had a fairly consistent gain going to all the boost levels, at least in the range that we're running it now. And we'll get a better idea once I hook up back pressure on the thing. And we're definitely going to do that, especially when we run the big bang stuff, because I'll be interested to see what's happening with the system that we decide to use, the exhaust side. I honestly think that what we're going to see mostly is the back pressure is going to be a function of the turbo that we use, more so than the exhaust or turbo kit that we use. I think that will have less of an effect on it. And we see that from other testing on other applications, LSs and big blocks and things like that. The turbo seems to kind of dictate what's happening. I suppose you could get, like, for instance, when we run the LS motor and we're running the Holley system, the cast, Holley turbo kit that they make, or Hooker turbo kit that they make, with the transfer pipe or the connection that runs under, and then they merge them into one manifold over on the side. That can get fairly restrictive. It's really nice for packaging and for different applications, for different chassis fitments and stuff. It works really well. But if it's not designed to be a race combination, because where they have to merge together and they exit out into a single 3-inch, as you might imagine, that can get a little bit restrictive for 800 or 900 or 1,000 horsepower combination. So you can have an effect on it. But I just don't think with what we're running on the 3800 that that's really going to be an issue. I kind of would like to try using the turbo or the tubular headers for that, just so that we maximize the exhaust flow. I haven't seen a power gain from those yet, but I can't help but think that at the power levels that we would be at, you know, if we're trying to get near 1,000 horsepower, that they should be better than the stock exhaust manifolds. But again, it would be interesting to see if we run that at, let's say that we ran a test at 700 horsepower and then swapped one for the other using the same turbo and all that. That might be something to think about to see if we see a change in back pressure or power at a given boost level. That might be kind of an interesting test. The other thing that the other test I've been thinking about that I want to run is I want to run a change in fuel temperature. We're definitely going to test that. And then I have some fairly cool stuff that I'm going to come up with to do on the LS engine family. We're going to do some testing with that some people haven't done yet. So it'll be some good stuff. What I want to know, and what the thumbnail that I posted and the information on the thumbnail was the thing that other thing that I wanted to talk about tonight is the fact that when we ran all of this 3800 stuff, and I've done this on other motors as well. We mentioned a few of the other videos that I have up where we're testing the different forms of horse induction. But the interesting thing is that, like with this 3800, we ran the same camshaft because we ran them with a bunch of different things. So we ran the same camshaft NA and with nitrous and with a blower and nitrous. So there's the thing. Which cam do you pick? Do you pick the blower cam or do you pick the nitrous cam when you're running nitrous and the blower? Which one of the cams do you use? Do you use the blower cam or do you use the nitrous cam to make it most efficient? So we run the same camshaft NA with a blower and nitrous, with a NA motor with nitrous, with a blower by itself, with a turbo by itself, with a turbo blowing into a blower, so a compound setup. Did I miss anything? I think we've got a turbo, a blower, and nitrous, and so we've run the same camshaft with all of those different power adders, and guess what happens? It just works, and it doesn't tell you that there are not blower cams and that there are not turbo cams and there are not nitrous cams. What it tells you is that if you get a good cam and it works, and it works fairly well, that the chances are it's going to work really well with all of the other things that you plan to put on that motor. You don't have to then get a different cam. If it's a good NA cam, you've got a really, really good start. And then you can just add to that with boost or nitrous and boost and, all of the other things. So it was good testing, and it's good to show the people that this is possible, because even people still send comments and send messages and stuff, and like, I just put I'm putting together a turbo combination and I have an NA cam in there, and should I just take the NA cam out? Should I run it with the NA cam now, or should I put the turbo cam? I'm just like, look, just put some kind of cam in it, as long as it's not stock. The stock one's going to make less power no matter what you do. So put a cam in it, whatever that is. In this case, like the little comp cam worked good. The NIC cam worked good, made more power. Not a lot, but some more power. So whatever makes more power, then it makes more power with all the other things that you would put on it. So just do that. Get good NA power with your camshaft, and then you can do whatever you want with it. You don't have to get another turbo cam to run the turbo. You can run that on your NA cam. You can run it on your stock cam. You can do all of that stuff. It all works out just fine. So let's see what kind of don't forget port it is. Let's see what kind of questions you guys had. I'll try to answer some questions tonight. Turbo cam or nitrous cam? Yes, in fact, it does. It works for all of those. I'm looking for max power out of the muffler choice. The advisor caught my attention when you mentioned that sonic turbo mufflers. The turbo muffler actually got its name from oddly enough, I think the story is that it got it from the Corvair turbo, and that's what they put it on. I have seen, or I think that I've seen, testing where mufflers had an effect on turbo combinations, but I don't have that data in front of me, and I don't know if it was from a restriction on the exhaust, because I know I've tested that many times. When we have a restriction in the exhaust after the turbo caused by having a full exhaust with a muffler, I did it on my Bonneville Honda. I did it on a supercharged combination. I've done the testing many times. When you have restriction after that, and I have the I have the banana in the tailpipe video up where we had exhaust systems and changed exhaust systems and made the thing more restrictive. It definitely has an effect on power. And so we see that, but I don't know if the design of the muffler, irrespective of restriction, also has some sort of weird tuning effect based on the turbo. I honestly don't know how it can. I don't know how any sort of tuning wave could get back to the turbo that's not a just flat out exhaust restriction and cause a problem with the turbo. I'd like to see it, but I'm told that it's possible. So somebody let me know. Anybody running stock 24-pound injectors at 450 horsepower at the crank? 24-pound injectors, that'd be a fairly high or a fairly good, fairly low brake specific number to be able to do that. 24-pound injectors, if you do the math, 24 times 16, 384. That's at a 0.5 brake specific. I know that the LS stuff will run in the certainly low to mid 4 brake specific numbers, and maybe better than that. You know, for really good ones, that we might see stuff in the high 3s. And you can also adjust that with fuel pressure. So I think you probably could get there. We've done over 400, I know, with 400 with 24-pound Ford injectors at the flywheel. What cam for a 6.2 from a Cadillac? Depends on what you want to do. Just tell me what kind of power you want to make and what you're going to do with it. Mike, my Whipple LS has a custom grind cam. I wonder if it's necessary to have a custom grind cam. Again, stop thinking about whether a blower needs a custom cam. Start thinking about what you want to do with your combination. Like if you saw a dyno curve of your combination, now tell me where you want more power. If you want more power down low and in the middle, you pick a cam to do that. Not a blower cam, just a cam to do that. If you want more cam at top, that's typically what positive displacement blower cams do, is they typically have a wide LSA. They push power out higher. They make less power down low because the blower has all that immediate boost response, but it has no runner length. So you can make the cam do what you want, but it's not specifically because it's a positive displacement blower cam. I remember watching glass packs burn out nicely on your 13B. Yes. Yes, you have to really have specific mufflers and exhausts if you have a rotary. What are your thoughts on aero chamber exhaust? I think that they've run the aero chamber stuff at Westech. Are the aero chamber ones the ones that the Holley guys own? Jacob, 216, 220, 600 lift with 112 LSA for Nitrous 4.8. Yes, you can run Nitrous on any cam. You can run it on the stock cam. You can run it on that cam. You can run it on a sloppy cam, sloppy best cam. You can run it on a Truck Norris cam. You can add Nitrous to any camshaft. It doesn't matter. You could make a lot more power with a different cam starting off. And then the thing is with Nitrous, like with Boost, is whatever NA power output you start with, you just add Nitrous on top of that. So think about making NA power. If you're also driving this 4.8 around, a 216, 220 cam is going to be okay. It's going to be, you know, a little more racy than driver on a 4.8, but it will still work. Brule did test mufflers and crossover pipes and X pipes. The Engine Masters guys did a good job of that. Daily, I'm considering using a single GT35 on an early 464 valve with max power goal between 500 and 600. That turbo will do that. I would have a fairly big hot side for a single GT35-82, especially for 600 horsepower. That's going to be about topping that turbo out probably on a V8. Everything Chevy. I have an LY6 motor, so a 6-liter variable VVT motor. 823 heads, so rec port heads, that's what it came with. Any idea how I can get 500 to 600 horsepower NA? Yeah, take a look at the videos that I have up. I show you how to do that. 600 horsepower is hard. 500 horsepower is really easy. 500 horsepower is just a camshaft. If you have your LY6, get rid of the variable cam. You already have really good heads. The intake manifold is already really good on that motor. If you put a 469 camshaft in there, the comp 469, which is a 231, 247 cam, I think, it will make like 530 or 540 flywheel. Slow Fiero, Dynamax 3-inch in and out turbo, ran 2/10 and 2 miles an hour faster than a Flowmaster 3-inch in and out dual 3-inch in and dual 2.5 out on my Fiero. See, if you do exhaust tests and good things happen. Any chance of getting a 3.8-liter Super Coupe getting the same treatment as a 3800? I'm not going to go down this 3800 rabbit hole again. Not with a Ford. First of all, it's not nearly as popular as the 3800. This GM version, I think they had a much bigger market for the GM motor, so there's a lot more stuff available for them. And whatever worked on this one will also work on that one. Ported heads work, cams of these kinds of specs work. More intercooling works. Nitrous will work. A turbo obviously work. All of that stuff will work on the 3800. Would there be a problem using a turbo that small on a 4.6? It's just going to have back pressure. It's not the turbo I would pick for a single one of those on a 4.6. Maybe for 500 horsepower I would, but not for 600. Would 5-inch full exhaust with high flow muffler on 1,000 rear horsepower turbo 4.8 or 5.3? If you have a 5-inch muffler, I don't see how that's going to cost power on 1,000 wheel horsepower. Hooker owns aero chamber. Okay, I thought that sounded familiar. I've seen those boxes of those mufflers at West Tech before. I don't think I've ever run them, but I think that they did. All motor 6.2 and then some boost. So are you more concerned with Gilbert? Are you more concerned with driving your 6.2 around and stuff? So like that sloppy best cam on a 6.2 will work fairly well. It would be a fairly good driver on a 6.2 because the motor's big enough. And it will work very well with boost, as they all do. Dustin cam specs grind number at 50, 231, 240, 631, 612. I don't like the 631. They don't need to have that much lift. It makes for a fairly aggressive ramp rate, and it can make for an unstable cam. I obviously haven't seen that on the Spintron, but that's just a generality. What's the deal with lobe separation angle? What does that? Well, that's designed into the cam. How much can just a tune get me on a stock 4802 Tahoe? It depends on how far off it is. If anybody knows, I don't know. I don't do that kind of testing. Whenever we do stuff, we optimize the tune for every combination. So I don't know how far off the stock one is. And then usually a lot of times on these tunes, it can become a function of they don't have full timing in it and they have it rich, which is how you gain power by taking fuel out of it and making it 12.8 instead of 11.8 or 10.8, and then adding timing to it, because if they only have 23 or 24 degrees and you add timing to it, it will make power. The thing is that if you aren't running good gas in it, you can't take advantage of that. And a 4.8 in a Tahoe is going to be struggling anyway, so that's probably why they have a fairly safe, conservative tune on there. Scott, Richard, can you port the lower intake more since you've gutted the supercharger? I'd like to do that. Actually, I think what would be best for what we're doing for the Big Bang deal is I would like to do the gutted blower deal, or maybe I was even thinking about making my own upper intake for the lower blower intake manifold, and then port the ports on it, and also use the Gen 5 lower intake manifold because it has a bigger opening. So I think it will flow more and be better. And then if I made a dedicated like sheet metal kind of inlet with a forward facing throttle body and then a big throttle body, I think that it would be better. I just want to use a different throttle body because I don't like the throttle body that we're using. I don't like that factory throttle body because it was originally a drive-by-wire. So I don't like how it has to close and then close some more, and it's just we have to put a throttle return spring on it, and it's just not good. How many gallons of coolant does the Superflow dyno have in reserve? We don't have coolant. It's just water. Noticing your intercore temps are very level. They are, because the dyno water tank is 2,500 gallons. That's to run the dyno. What compression are you running on your test motors? It depends which one. I have test motors vary all over the place with compression. Picked up a 302 with 9-to-1 compression. It might have more. Can I turbo it? Is GT40P heads? Yeah, those are not ideal heads for a turbo. They're iron, first of all. Aluminum would be better, but yes, you can put boost to anything. You're going to have to balance. I'm hoping that you're going to use an intercooler. If you use good gas, especially E85 would be even better, would be ideal. So then you have to balance. If you're going to try to run it on 91 or 93 pump gas, you're going to have to balance compression and octane and timing. The engine builder had it custom ground by comp cams. Okay. And by the way, for most guys, you don't need a custom cam. I mean, you did it. That's fantastic, and I'm sure it'll work well. But you don't need a custom cam to make lots of power. You can do that with almost any kind of shelf cam. Love to see you try F1 agricultural passive pre-chamber spark plugs on high compression. I don't even think I've ever seen those. Most racers I know have a boatload of cams that they already tested. So if your best cam breaks, you go to the shelf and get your second best cam. I know Brule was telling me, and I think it was, who's the, might have been, who's the big block cylinder head guy? He had done a bunch of testing for Pro Stock, and he had like shelves of camshafts that they had run, ones that didn't work. And and when I say didn't work, maybe they went down a different direction and wanted the combination that they were running wanted a different kind of camshaft. They had literally, I think, probably hundreds of camshafts that they had run, and so all of those were potential ones that they could put back in. Australia's in the house. Anthony, I got an L36 turbo auto, 9.5-to-1 compression, 98 fuel, 331 rear wheel horsepower. Hoping to go with a cam upgrade and decomp. So I think you're talking about lowering the compression to get 400 wheel horsepower. Hoping maybe 3,000 RPM stall. So how? Oh, it's an L36 turbo. It certainly can make more than that. I mean, a cam and that motor with boost can do 100 more than you're talking about without too much of a problem. Andrew, do we still choose turbos based on flow and pressure ratio? I choose turbos based on what the desired power output is. So I want to, if you want to make 1,000 horsepower, you need a turbo that's capable of flowing enough air to make 1,000 horsepower. And then you would go, if it has a map, that would be awesome. If it has a compressor map, then you could go look at the compressor map based on you need to know your NA power output or have some sort of airflow data. And you could take a look and figure out where that's going to be on the map to make that 1,000 horsepower. If it's a 1,000 horsepower turbo, it's going to be to the far side because that's where you have to be to maximize the flow rate of the turbo. At what size does post-turbo exhaust become a power loss with larger diameter? You're not going to lose power with a larger diameter exhaust. You're going to gain power with a larger diameter exhaust after the turbo. And as you make that smaller and increase exhaust restriction and increase back pressure, you're going to lose power. Jared just picked up an M122 supercharger. Nice. Put on my LM7. That'll be fun. I love Snake Eater for being a veteran-owned business. So the snake, I've used the Snake Eater stuff a lot, and I've had good luck with all the stuff that I've used. Anyone know roughly what injector size I should be looking for? It depends on what your power output is, but you should put 80s in it. They'll just like skip to the chase here. What amount of duration can you run before piston to valve clearance begins to be critical? The cam in question, 230, 236 at 50 if this is on an LS and on any kind of factory LS with factory piston to valve clearance, it's different with different strokes and different valve drops from different heads. So there's a lot going on. But in the 230 to 235 range on the intake duration, you don't have to worry so much about the exhaust. We've gone to 248 on the exhaust, so you got a lot of room there. But in the 230s, and then is going to be the testing area. The comp cam 469 cam works good. I have tested that one a lot, but also it's not just that cam. That's not a magic cam. Anything that has specs like that is going to do the same thing. Admiral's in the house. How long will my stock bottom end LS1 live at 12 psi on pump gas with a Matt Habelton? Already have all of the above. I don't know. Matt's pretty good at tuning the factory stuff, so he knows how to make them work, especially on pump gas. He's done way more, but I don't do hardly any pump gas stuff. So his tuning is pretty good. So it should last a long time, as long as you know, I want to know how long you're going to stay at 12 psi. What does lobe separation do to the power curve? Well, lobe separation by itself doesn't do anything to the curve. It's part of what's going on with the camshaft. But that being said, traditionally, we were talking about positive displacement supercharger cams, if you look at a factory LSA or LS9 camshaft, it has a really wide LSA. The reason that they did that is because from the factory, they're trying to do something specific. They're trying to make the car idle well. They're trying to make the camshaft last a long time so that and trying to get it to make power and trying to work as a blower cam and trying to have good emissions. So they're trying to do a lot of things. But that camshaft has like 120 plus, 121 or 2 or 2.5 degrees of low. It has a 122 LSA. Most cams, like the other cams, are tighter than that. They're 115 or 116, a lot of the stock camshafts. And then when you get camshafts that are making lots of power, they can be even tighter than that. So they push that out in an effort, and they have lots of exhaust duration on that camshaft too. So they're pushing it out. They push the wider LSA, helps with a couple of things. One, it pushes peak power out farther in the RPM range in this particular case. It also improves idle quality if they have a wide LSA combined with their intake and exhaust duration split. So they've cured a lot of things by doing that. That's not universal, though, on every camshaft. What is a spintron? A spintron is a machine where you can put an engine on like a dyno, except it has a big electric motor, and it just spins the motor. The motor isn't actually running. It is not doing an internal combustion thing. It's not, the spark plugs aren't going. It's not delivering fuel. It just spins the motor at RPM. And they have all kinds of sensors on it that are measuring what happens when the motor is running at that speed. So they have sensors on the camshafts and the valve springs. They can check deflection, and you can watch and monitor valve loft and valve balance and all kinds of really good information. Would 80-pound injectors be too much on a mildly built LQ9 with a sloppy cam and a tune? No, it wouldn't. You're not going to, the 80-pound injectors wouldn't cause you any problems. You can any kind of tuner can easily make those things idle well, and you have enough injector to do other things later on if you want to go up. Turbos with the same hot side, a T6, 1.32 AR, and the compressor side, one with an 88 millimeter, the other with a 75. Would it be a big difference in boost response? Yes, I think it would. I think the 88 would be laggier. And some of that is going to be a function of what you're trying to make it respond with. You'll see a bigger change in boost response with a smaller motor. So if you have a 550-inch motor, neither one of those are going to be laggy. So as you go up in more NA power and more displacement, the difference between those two, any sort of response rate change, is going to diminish with much more motor. AAR Volare, cool. Pre-Magnum LA318. I just ran one of those the other day. As somebody, it just belonged to somebody else. All I did was run it on the dyno. But LA318 roller block. Okay, so it's a late 318, but before the Magnum came out. Build done. Just waiting for the heads. 2.5, 2.5-inch exhaust. So does it have headers on it? 750 Holley. Can give me what turbo setup. I don't know how much power you want to make, but the GT45 that we ran on this 3800 is like a 700 or more horsepower turbo, be more like a 700 horsepower turbo for that 318. So if that's in your wheelhouse and that's the kind of power that you want to make, that turbo would work fairly well on that. Can you big bang an EG and or an FA for us? I know it's your specialty, but it would be entertaining. An EG Honda? Is that what you're talking about? Have you done any turbo Jeep 4-liter inline 6-cylinders? I have not. I've never run a Jeep motor on the dyno. I already have a GT45 for the 4.6 4-valve. I just thought a GT35 would be more responsive. If they both package it, when you make this, package it so that the big one will also fit, and just try them and try the GT35 and see how you like it, and then try the bigger one if you find that you want more power. What are the effects of tightening the LSA on a turbo application? Everybody wants it. Well, what happens if I change lift? What happens if I just change lift? What happens if I just change intake duration, or just exhaust duration, or just LSA? It's not a universal thing, but a tighter LSA tends to decrease idle quality, but improve low speed and mid-range power. Richard, I was able to complete the assembly of my 6-liter, but due to unforeseen medical expenses, I'm sorry to hear that, man. My install is on hold. Understandable. So close. The Spintron doesn't test engines, complete engines. It's really more for valve train. The engines are usually, the block a lot of times have big cuts out of them so that you can put sensors in. It does have oiling going to the motor because it has to have that to spin it, but there's no fuel delivery. There's no spark, there's no ignition, there's no internal combustion. The big electric motor just spins the motor, and they find out how much. This gives you a really good idea, because the valve train, as we've talked about many times when guys are talking about bore versus stroke and D-stroke motors and all that, the valve train really is the limiting factor in terms of engine speed. And so they want to find out what's going on with engine speed. The guys at Brian Tooley, guys at Comp Cams, guys at Skunk, they all have Spintrons. And so you try to find out what's happening with, because a lot of these guys will make camshafts that have these very aggressive lobes, and they make power. So if you have, for instance, a cam that's 220 degrees of duration at 50, but it has 700 lift, that has a fairly aggressive ramp rate. The problem with that is you can make power like that, but it becomes unstable. And so you have valve train instabilities that cause all sorts of problems. They can cause RPM potential problems, that you can't rev the motor because it just goes into valve float, bounce, loft, whatever kind of associated problem it is. you run into valve control problems and that you can't cure with just more spring pressure. In fact, a lot of times more spring pressure exaggerates the problem. So obviously there's a sweet spot in designing these camshafts to get not just maximum power, but also stability and longevity. So if you have a camshaft that, oh, this camshaft makes 5 or 8 more horsepower than the other one, great. It only lasted 5,000 miles before it beat the lifter to death, or beat the valve tip to death, or beat the camshaft to death. You know, those are all things that are very, very important. And those are things that a lot of guys find on Spintrons. What's your opinion on comparing a 2J to a 7M GTE? I don't have either one of those motors, and there's the 7M GTE would interest me way more than the 2J. I think the 2J's kind of been done to death. Richard, can you do a crowd favorites muffler shootout? I want to see what those turbo mufflers really got. So do you want to see it on a turbo application? The problem is I run 4-inch turbo exhaust on most of this stuff. Some of it's 3-inch on some of the twins. Yeah, Dan, I know you've used Spintrons. You do kind of know how they work. Provided all hardware is torqued correctly, can a paper or rubber material gasket seal the same or better than a silicone gasket maker for carb intake now? If you're just sealing the carburetor, you could use almost anything. Converting my daily driver 67 283 to a Sniper 4-barrel EFI. Oh, man. With a Performer EPS dual plane intake, looking for torque, drivability, would you notch the plane divider for the EFI? No, I would not. I would leave the divider there. You'll have much better signal if you do that. Is the L9H a good engine? Yes, it is. Do you ever stop and get 100 octane from buttonwheel to run in your test? If that question is for me, no, I wouldn't ever do that. Could you make a list of suggested boost and total ignition advance for all popular stock engines with intercooled boost on pump gas? No, I can't. That'd be quite a list. I'm looking for, because it would vary by a lot of different things other than just boost and timing. I've been looking for a 3800 for roughly a year now. You should be able to find lots of them in the wrecking yard. Anytime we go to the wrecking yard, there's like 10 of them there. I've been told that the L32, so the later version of the supercharged motor, is the best one, and that it has stronger rods. So if you're doing that, a lot of guys will put the higher compression NA motors with the top swap deal where they put all the supercharged stuff. And that's actually something you could do at the wrecking yard if you want to put that kind of time into it. Go and take out an NA L36 or an NA version of the 3800, and then take all that stuff off and then put the supercharger stuff on top of that version, and then just go buy that as a complete motor. Richard, I'm looking for a T56 swap for my 6-liter LS. I found one, but it's for an early gen small block. How hard is it to swap out an input shaft? I've never done an input shaft swap out of that. Is the bell housing, the depth and all of that is the same? CRH Garage, I said 3 to 5 pounds is all I wanted. Now I'm at 16. So 10 or 11 later, I'm out of fuel injector. Yeah, that's right. And that's the thing. What are your thoughts on camshaft gear drives? Yes or no? I don't run gear drives on small blocks or anything. I thought people kind of did that for noise. Maybe it's better for accuracy, but I just haven't seen that. So Fiero, just get a supercharged version and swap that. Yep, 3 to 5, 16, and now and then 20. A D16Y8. I'm late. I had to watch the Freiberger video on blower cam debate. One aspect of the result was the blower cam wasn't as bad down low under boost versus down low without boost. I'd like to see that because I don't really understand that. Whatever the motor does, whatever the camshaft does NA, it's going to do that under boost. Oh, the Subaru engines. Okay, an EJ or FA. Okay, that makes sense. I've never run a Subaru on the engine dyno. We don't have bell housings or any of that stuff for a Subaru. Have you ever removed valve guides from any LS? I have some that are pretty stuck for replacement. I haven't done it personally. I would take that to the machine shop and have them do it. Dan, that's a really good point. The gear drives can transmit harmonics from the crank to the cam, and I've heard that. And because if you look at cup motors, don't run. None of those guys ran gear drives, even though they're running lots of RPM. A belt is better because it absorbs some of the harmonics. A chain is second best. See, that's Dan throwing out all the tech, man. A 4-liter Jeep would be good, and that is planned along with the inline 6-cylinder Ford, the 4.9 liter 6-cylinder, the 300. I want to do that too, just because I think that they're cool, and the Jeep also would be good. If you're looking for Fieros, yeah, definitely look in the non-rust areas: California, Arizona, New Mexico. Is a Spintron what the factory uses to test motors? No. I would really like a Fiero with a 3800 in it. I think that would be awesome. Jay gets censored. I got what you mean. I know that you want me to do a big bang on a Subaru motor. I get that. I don't have those and have never run those, and we don't have a way to set them up on the dyno, unfortunately. How is sealing? How is head gasket sealing on the Subarus? Do they get good sealing from those things? Good cam for an LQ4 with an S480. An S480 is like a 1200 horsepower deal. On an LQ4, you can run a fairly decent sized camshaft in it. That new sloppy best cam would get everything out of that S480 if you want to also drive around. You can put a bigger cam in it. How do you safely optimize or maximize timing with boosted applications? What should the guys who are learning to look for to know when to back off if you're still making power before destroying a motor? You should be patient and happy with what you have. You should look at what people are doing. For instance, the stuff when we're running on the dyno. If it's running really well at 20 degrees, there's no reason to put 22 degrees in it, even if it will make a little more power. Because the more that you put in there, the closer you get to detonation. And unless you're racing in a class where another 5 or 8 horsepower is going to be the difference between you winning and losing, because it's going to be the difference between you having a motor and not having a motor. So if you get to go out, I'd rather have a motor that I get to go at, that I leave 10 horsepower on the table and go out and drive it every day and just beat the heck out of it. That's the combination I want. I don't want them one that wins the internet contest. Oh, mine made this much power. I don't care about that anymore. Man, I saw a question that I wanted to get to, but I must be way late in these things. What turbos are needed for a twin turbo setup for an LQ4? The goal is 1100. Pick 2 GT3582s. $3,800 turbo to M90 video. What's the title? I've looked and can't find it. It's the video that I just posted on my channel. It's the latest video other than this one right now. Can you do a shout out for your wife? Eleanor, what's up? Rumor has the L32 rods tend to break in glorious fashion where the L67 rods just bend at the limit. I'm wondering about comparing 100 octane to E85. E85 makes more power. We've already run that test. Weldless cam for stock bottom end 5-liter with GT40P heads. I don't know. I don't even know if the 274 cam will fit with GT40P heads. You definitely have to measure it. I have an L83 5.3. I want to do a ported factory head with boost. How much cam and turbo to make 600? If you're trying to make 600, if it's FW HP flywheel horsepower, you don't need to do anything to the heads. You just need to add a cam. I mean, you don't even need a cam. You could just put boost to it, and 600 would be really easy with that motor. It already makes over 400 by itself, so you're going to do that at like 7 pounds. The Magnum is actually in my garage, and the odd thing is I went to Harbor Freight today to get an engine stand in my haste leaving from West Tech. I loaded the motor up, and it still has the stock for the engine stand, but I didn't put the rest of the engine stand in the truck. So I just came with the engine, and then it has the thing to mount the engine, but not the stand. And so I went to Harbor Freight to get a stand, and they were out. So I need to find a stand from somewhere else so I can put that motor on the stand, and then I plan to disassemble it. What year motor is your 5-liter? My 5-liter is that might be for somebody else. Mine is an 88. The days of junkyard under 100,000 mile L67 blocks are basically over. I don't know about the under 100,000 mile. We find a lot of motors there, but I'm sure that they're probably all high mileage. I think the 2.6 pulley with NIC cam was spot on without good heads. I'm very nervous about the heads I bought. I don't think you have to worry about that. I think that these just didn't add any power. Yeah, the gear drive does make the blower noises though. Steven, stop worrying about LSAs and turbos. Just the cam that you have works fine, and you have a turbo and you have a cam. Guess what? You have a turbo cam. It works just fine. You didn't leave power on the table. Whatever the motor does NA, you just add boost to that. Start thinking about it like that. The signal for the EFI is not required nearly as much as with a carburetor. You're absolutely right. But if you said you were concerned with drivability and torque, and so having the divider there is going to do that. And also the signal is going to affect the map reading, right? Have you thought of doing some testing with a 225 slant 6? I have videos up on the slant 6. Unfortunately, it was broke. So I have one already, and we're doing stuff on it. I also talked to my buddy Jimmy today, who has the J Series Honda in the NSX. He's driving around, is running boost. He's fixing a few things. He has a flex fuel sensor on it, and so he's doing a few things with the AEM. And so hopefully he should be on the dyno before too long, and we get to see some videos of that. So I'm going to go down here to where people are at. Yeah, they didn't have any engine stands. And I wondered if the local auto parts stores have any engine stands. I just need to get one. Can you send me a tune, which I'm sure it's not tone, for a Holley Terminator for a L96 way space for BTR Chem 6-liter 5 gen? I also have a Holley. I don't know what any of that means. I don't have any tunes, and because I'm not a tuner. Yes, everybody hit the like button. Do I need bigger injectors for a 200 wet shot? No, you don't. Any interest or plans to run Nissan V6? I would. I'd like to run. I like the Nissan stuff. I have a 240Z and I have a RB25. Sometimes you just need to take a stand and then deliver. So you stand and deliver. Hey, Richard, you should have common cam replies and ring gap recommendations posted behind you. I know. Yes, it's a turbo cam. Auto parts stands are way more expensive than Amazon Prime ones. They are. I don't want to order one. I need one right now. I was surprised when I went to Harbor Freight and the stand I was looking at, it was the 4-wheel stand and not the tripod one, but it was $79. I thought Harbor Freight stands were $29 and $39. What is the first mod to an L32 or L67 motor? A pulley is the best thing for a supercharged deal. How do you like the MS3 Pro versus the Holley management system? As long as I'm not as familiar with the MS3 Pro, but it worked very well on the 4200 on the Atlas motor and allowed us to change cam timing thanks to Eric setting everything up because he worked his magic. But it allowed me to do cam timing and ignition timing and air fuel. And that's really all I care about. I'm not a tuner, so I'm not going to take advantage of, even 20% of what all those things have to offer. But as long as I can do the air fuel and the timing, and in this case on the MS3 Pro and the 4200, the cam timing, as long as I can adjust those and go more or less, it shows me what it does. That's all I care about. How critical is ring gap for a 5.3 with an LSA blower? It's not if you don't want to run any boost. If you want to run boost, then it's important. You have a 416 Dart Pro 1 heads, most likely LS3 intake, 11.4. So that's got some compression. What's the best cam for a driver pleasure trip mobile? So that's a lot of compression. And if you're going to have it as a daily driver kind of thing, you're going to want a small cam. So that compression and a small cam and an LS3 intake, it's going to be, a little iffy on detonation. So I'm thinking that something that's going to be like that. Look at something like the, for a driver, look at something that has specs like the Comp 54-454-11. So like a 227, 243 kind of thing should work well. Turbo is the first mod for an L67. Obviously, the video kind of showed that for a lot of people. I did ask Harbor Freight to check the other local stores. They did, but the one I was looking at was in Fairfield, and they said the closest one was in Woodland, and I didn't want to drive to Woodland. Big Block Chevy header diameter for 489, engine 3/4, probably small. Are you still planning on going back to the Cadillac engine? I'm just going to put it back together and run it. I'm not going to do anything to it. Yeah, slow Fiero, the as we showed in the video, the turbo stuff is so much easier to make power than it is with the M90 blower. Because even if we went down to a 2.5 or a 2.4 or 2.1 or whatever, I don't know what guys are running on. I don't know how small we can make the snout on that. But even spinning the heck out of the thing, even running lots of engine speed and spinning that thing, you cannot make what you can easily make with a turbo at a much lower boost level. Yeah, a 2 1/8, and I think some of our stuff for the engine dyno I think is even bigger than that. So what is it? Slow Fiero? I'm interested in doing a Fiero. So how are you making that thing work at the drag strip? Is there going to be a Truck Norris cam video? Yes. There will be a Big Bang 3.8 liter. In fact, that's probably going to be the next thing. I might run some tests while I have it up on the dyno of different things, but that's what it's being put together next for. Okay, guys, 2 more minutes. Lots of money in transmission. Okay, swapping to 4T80 now. Okay. Ever do anything with a 3FE or a 1FC? I think only on the chassis dyno. We've never run one on the engine dyno. Paper versus silicone. You need to get past the gasket thing. Gaskets work. Put a gasket on it and seal it, and it works just fine. Spend the money and go EFI and boost, or stay carbureted and add nitrous plate. With a turbo, you'll be able to make more power than you can with nitrous, but both of them could effectively achieve the same thing if your goal is like a realistic kind of goal. Have you ever tested CO2 spray? I have the intercooler ring that you put on an air-to-air intercooler that we ran nitrous through it. You could run CO2 through it, and that would work too. Had my Fiero running well at the strip, 11.0, 122. It's in the single digits now with 680 and medium boost on the turbo right now. So what's the drivetrain in that? What's the trans and stuff? Richard, would Texas Speed Stage 4 cam with a turbo 5.3? I wouldn't recommend it. That's way bigger, too big. I mean, it's not too big, but it's a camshaft that you don't need to be. Doesn't need to be that big for a turbo. Tom, it's negative 15 there. Well, perfect for perfect turbo weather, right? I have a 7ME if you want to do testing with. I would like to do testing with one of those down the road, but that's years away. Whipple 2.9 or Pro Charger with 12 to 15 pounds of boost for a 2017 Tahoe daily driver. I think I would pick the Whipple for that, as long as the trans will stand it. What do you think about the Air 5 tranny? I'm not familiar with it. I'm not familiar enough with it. Yeah, I'm all for big brakes. That was one of my favorite things about when I was driving for the guys at Bear Racing is our cars had good brakes on them. I saw the camping trailer. I saw Farm Truck and Asians deal. That's cool. I love the farm truck boat that they did. And I like when I was showing my kids way back when they were driving around when they were hidden themselves inside the seats. I thought that was really cool. The little Halloween deal. And then this trailer thing is pretty funny. Uh-oh, you got a hole in the piston. That's not good. Russell, you'll have the last question. Would a 223, 235, 115 LSA, 610, 620, the lift doesn't really matter, on a 6.0 be streetable without a converter? A 223 is going to be a little big for a stock converter, even on a 6-liter. Obviously, that'd be better than trying to do it on a 5.3 or a 4.8, but 223 is still a fairly good-sized camshaft. And a 223, 235 split. The 115 can help you a little bit because it's fairly wide, which should help you with like idle and drivability. But I still think you're going to need a converter with a 223 intake duration. Thank you guys all for showing up. Hopefully everybody's taking a look at the video that I have up on the turbo versus the blower, slugfest. That's always good. I've got more stuff coming up. Obviously the sloppy and the Trek Norris deal, that's going to be really good. And then we'll follow that up with the header test and the exhaust test on those motors. So it'll be really good stuff. Thank you guys all for showing up. I will see you all tomorrow.